Okay, I guess I'm gonna start Google Code Jam. You need 30 points. So first one looks like everybody has done it. 7 points, 16, 19. So 42 points in the first 3 problems. Okay. So let's see. Seven points. That's it. TM means trace in Latin. The trace is the sum of the diagonal entries. Latin square. We know what that is. If not, you can read it. Compute the trace and where there's a natural Latin square. To give some additional information, is that simply telling us whether it's yes, natural Latin square or not. Please compute the number of rows and number of columns that contain repeated values. First line, T cases. Each line starts with a line containing a single integer n, the size of the matrix. Then basically the matrix. Okay, that seems really easy. I guess the only question is there any way to make it easier in terms of implementation, but it doesn't really matter. Fastidium.cc. Okay, so that's just the skeleton. Now let's solve the problem. And it's up to 100, so call it M, the way that they have it, C and N. And then we want the trace, and then the number of rows that contain repeated elements, the number of columns. So there are a number of ways you can do this, but there's no real complexity issue, so we'll just do whatever is easiest. That's the trace, and then the number of rows and number of columns that have repeated elements. So, like I said, there are many ways you can do this, but we'll just use a set. I know it's not necessarily the most efficient way, but whatever. So for each row, so if the number of things in my sets. It's not and, that means I must be repeated one. So I increment the number of such rows, and then columns are more or less the same. But of course, I switch INJ. You probably should not do this, but whatever. Only professionals should be doing things like this. And let me just read the code just to make sure I didn't screw up. Should I compile this? Sure. It's fine. Is there any easy way? Okay, so upload file, contest, practice code jam 2020, qualification. Here's my code. So what language?
What's your P?
There. Got to pause. Okay, I got to unpause this because I have to deal with some family stuff. Okay, so I have the file here. So what do I do? Show test input. Actually, I don't know how to use this interface. Should I just copy this over here? Okay. Run test. Oh, did I just submit? Oh, okay. Okay, I guess that wasn't a submit. I wasn't sure what this interface is about. Looks right, I guess. So what should I do? No. Okay, how do I submit now? Completed. Completed. Okay, I guess that's done. Problem B, nesting depth. Nesting depth.cc. I can probably reuse the main, but let's just quickly see case one, read in T, case one, case two. Okay. All right, let's see what this problem is about. TLDR, given a string digits S, insert a minimum number of opening and closing parentheses into it, such that the resulting string is balanced and each digit D is exactly inside exactly D pairs. Blah, blah, blah. Okay, so I need to insert parentheses. Length of S is at most 100. Test set 1. I see, okay. Let me clear, do I need to clear this? Okay, what to do? Okay, so 0 and 1. Let me get the whiteboard here. So if only zeros and ones, then I believe the solution, the 0 basically means that nothing can enclose it. And then it's just a matter of putting brackets around blocks of ones. I don't think there's any better way of doing that. So, okay, so that should be easy for that case. So what if there are other okay, so let's say we have this. 0 cannot be in anything. So immediately I think if I see a 0, anytime I have a 0, I essentially break it into substrings to deal with. I think that's true. So if that's the case, then I can pretend that I have a string with no zeros. So let's think about this. 1, 2, 3, 1, 2, 4. Okay. So what to do? I can put a bracket around everything. So then recursively, I can think of this having to wrap this many more brackets around that. So I just subtract 1. And then I can play the same trick. I can say, well, zeros don't have to do anything. So I put the zeros here. And then the 1, 2, I can recursively do this. And it will be something like 1 and 2. Something like this. Is that the minimum? Okay, so what am I saying? If I see zeros, I break it apart. Do the substrings. If the minimum is 1, if the minimum is whatever the minimum is, if it's bigger than 0, then I put one set of brackets around everything, decrease everything inside by 1, and recurse. I think that's it. Why is this minimum? Because I always use brackets to surround as many things as possible. Okay, so I think, let me square this again. I think I'm ready to code. So this strings is at most 100, so I don't have to be efficient. I can do whatever I want. Doesn't really matter what I have. So I'm going to find the minimum. In the string. So if I have recursions, I have to be a bit careful. I don't know if I'm ever going to have to worry about this, but it wouldn't hurt to have it. If I have an empty string, then I just return nothing. Otherwise, I look at the minimum and remember that this is an array of characters, the collection of characters. I have to take the minimum, which is the, let's do this so I don't collide with the word min. If I see 0, then what do I do else? Something else. Okay, something else is actually easier. So something else is, I say, I subtract 1 for every single, so if the minimum is not 0, so it's at least 1, I'm going to subtract 1, then I'm going to form now, of course I can't do this because I have passed s by reference. I can't change s unless I pass by value. Okay, so what just happened? I'm recursively computing this after I reduce everything by 1, and I put brackets around the whole thing. So then, otherwise, I'm going to be a little bit careful here. I'm going to have to break it up. So if SI is not equal to 0, continue. Otherwise, I have to do something. I have to break it up. So why do I write this with continue instead of the other way? If SI is equal to 0, can do something, because then my nesting depth is a little bit lower. It makes it easier for me to follow. Okay, so now that I find a 0, then I want to recursively say answer plus equals to f of what? Well, I need a last index from last to s dot substring from last for I minus last characters. And then at the 0 character, and then last would be I plus 1. Okay, let's just think about this. This is a little bit tricky. It's not really that tricky, but I just want to be slow and make sure that I don't screw up. You might have some zeros here. So I'm looping over at the beginning last is at 0. So I have I characters. And then last, it's going to be I plus 1. And when I get to I, again, it's I minus last character, and so on. You always have to worry about a few things. What if the next one immediately is, maybe the first one immediately is 0? Well, in that case, I minus last would be 0, and then you would move last up, so that's fine. Whenever you do this sort of thing, you also have to worry about, are you going to grab this last chunk properly? So the answer is no, because I only grab the chunk when I see a 0. So unless I see a 0 here, for sure I will lose it. I will have to write an extra, extra statement at the end to grab this chunk, or I just stick a 0 at the end at the original string, and then we don't have to worry about that. So we add a 0 at the end of the string to force that. And then we don't have to worry about this. But then my string is too long because I have an extra 0 at the end. So I'm going to say return s dot substring 0 s dot length minus 1. Okay, so let's just read this. This is the tricky part. The other part is not so tricky. Let's read this part first. I'm subtracting, and these are not numerical value, but ASCII characters, but subtracting anything that's non-zero is okay. Let's just give me the right thing. Okay, got this, and recurse, then that looks okay. And here, if it's 0, stick a 0 at the end. Okay, I think we're close. Completed. What does that mean? Does it mean correct? Oh, I never printed the answer. Oh, silly me. Okay. Okay, that Unfortunate. Okay. Hopefully that's better. Well, that is not good at all. Okay, so what did we do wrong? 0, 0, 0, 0, fine. 1, 0, 1. So that should break f into that. And then when it gets ones, actually maybe look at the last case. If I get 1, I get round bracket 0. Oh, because I'm using the old string. I'm using the new string. Okay. That's pretty bad. Aha, because right. Problem was that I subtracted 1, but then I forgot that I changed the string. Okay. Hang on. Where was the? Okay, what about the other case? Do I think that would work? So case 4, 0, so I would be doing f substring last to I minus last. So I should be calling f of 1, 1, 1. And now come over here. Okay, I'm going to run it locally. Okay, that's good. That's not good. Okay, so somehow things are not breaking the zeros. Min element, if it's 0, so I should be here. I should see another 0. What the hell is this? I forgot to return the answer that I computed. Okay, try again. Interesting. It's too many ones. Oh, okay, yeah. Now I remember why I did this. Because I got to remove the trailing zero. Okay, so now you see how I intentionally introduce bugs. Ah. Okay. Okay, better. Okay. Now that I think we got all the bugs out of the way, upload. This is not my test. And this, oh shoot. I uploaded my source file into here. Okay, try again. Okay. How do I submit? Okay, here. Okay, took too long. So how many points do I have? 7 plus 5 plus 11, 23. That's not enough. So I better go on. Where's my standings anyway? How do I see my standings here? Oh, I just didn't have to check. I am 5,000, whatever. Okay, fine. How many people have solved all 4? Oh, not everybody. Okay, all right. Let's see this problem. Cameron and Jamie's kids is almost 3 years old. List of N activities. Activity happened during a specific interval. They need to assign each activity to one of them. An activity. This is important. An activity that ends at time t is not considered to overlap with another activity that starts at time t. For example, 3 activities, 18 to 20, 19 to 21, 22 to 23. Another valid schedule of people can and to cover the activity 18 to then. Notice that the first two, blah, blah, blah. Given the starting and ending times of each activity, find any schedule that does not require the same person to overlap, to cover overlapping activities. We'll say it's impossible. Integer n, number of activities to follow, then it's SI and EI. The ith activity starts exactly SI minutes after midnight and EI minutes after midnight. Okay, all these numbers are pretty small. For each test case, I'll put one line containing case blah blah blah. Ith activity is Cameron or J. Then for solution, print any one of them. Okay. Well, this is kind of a standard thing. So what to do, right? I mean, you got a bunch of intervals. There's start and an end for each interval. So the standard thing is to say that the starting point is, I don't know, a certain event, and the ending point is another event. So there are two types of events: the one that starts an interval, one that ends an interval, and then the event would consist of a time and whether you enter or leave the interval, and an ID, which event, which interval it is. You sort all events based on time, and so sort by time, and because ending, if two events, one ends at 1 and one at time t and starts, another one starts at time t, they don't really overlap. So you usually, in this case, if there's a tie, break it by leave comes before enter. That's usually how that goes. So that when you're scanning these events forward, you're basically asking, what is the next thing to do? If you enter and so you keep track, you scan forward in the events. If you see an opening, and you keep track of who is occupied right now, right? The event ID, and also remember who it's assigned to. Yeah, so you scan this event, and when you see, let's say this is 1 and this is 2, when you see open, you assign it to anybody that's not used right now. And if you ever run out of, so here when you see the second event, you would assign it to the other person. Now this frees up the first person, this frees up the second one. If you ever have to assign something and there's nobody that's free, then you're done. So that's pretty much how this type of problem is typically done. So let's see if we have a better luck doing this one than the last one and not screw up so much. Okay, so I can keep the main again. Solve, oh, shit. I better save it to some other problem first. What is this called? Parenting. Okay. So first thing is n, int n, c and n. Then there are a bunch of activities, which is, so I need, I'll just write struct events, int se, int ib, int who. I'll just say 0 and 1. Okay, doesn't really matter what they're called. Two people, 0 and 1. So I have events up to 1,000. So I equals 0, I less than n, I plus plus, c in ei dot start, ei dot n. Is that what I want? No. Because I actually need 2 of these things. Okay, so I actually don't want to. So what do I actually want to do? Okay. Activities, 1,000 of them. Then I'm going to read in okay. So this is the activities, and then E, I have to have what? Okay, if I dot S is equals to X, I'm going to create 2 entries. The event doesn't really have 2 things, just one time. The first entry is for entering the event. I'm just going to do this. Events. Let's take event xi dot first. ID is I, enters true, and then 2i plus 1. Okay. Then I'm going to sort the event. And I need a comparison operator. Okay, what am I doing? So if time is not equals to e dot time, return time less than e dot time. Sort by time. Otherwise, they're equal, then return Okay, I'm going to convert. I don't think I need to actually explicitly convert, but let's be safe. That would be 0, 1. So 0 is false. False means leaving. I want leaving to come first. So I sort them. And then I'm going to have an assignment of who is doing what, 0 and 1, and who 3, 2. Okay, use is going to keep track of who is being used. So what am I going to do? If and if I'm entering, and if I'm leaving. I think leaving is easier, so let's do that first. If I'm leaving, then use ei.id is equal to false. That's it. Okay, I free up that person. If I'm entering, I would look and say, what I want to do. If use 0, C++. So basically here, I'm checking if I can set who do I assign it to 0, 1. If C is greater than 1, then I know it's impossible. So what is it that I output? Impossible. Did I have a space? Space already. And in this case, I can actually quit. Otherwise, it's possible. So use C, it's equals to true. And I got to assign could be C. And if I go through all of this and it's still possible, then basically string, what do I want to call it? I just print out the character for who. So these S bracket who bracket I. Compiler. I forgot to write this. Okay, well, the rest of the compiler is meaningless. Oh, I can't compile this damn thing. Okay, so oh yeah. Okay, I need the default constructor because I now declare an array of these things, and that's it. Okay. Completed. No, that is definitely not right. Okay, let's see. So the first one, it just prints one thing. 360, 480, 420, 540, 600, 660. Okay, it reads and so then it scans. The first one that displays should be 360. Then it should see 420. And then it should see okay. All right, let's see here. So first event is 360. That's the first event, belong to first thing entering, then 420, then 480 is this first one leaving. Wait. What? It's producing the right thing, but what did I? Oh, okay. I printed too many end lines. Got confused. I mean, there's still something wrong in third case, but maybe it's not as Okay, CJC, that's one possible solution. Second one is impossible. That one I got CC, so why is the fifth one possible? So fifth one is here. So the first event belongs to time 1, index 1 entering, then time 2 entering, event 3, 5, 99, okay, so somehow I am, let's see what's going on. So when I see 1, when I see time 1, events ID 1 entering, I should be here and then assigned first person 0. Okay. Then the second event 2, and then he leaves. Oh, what am I doing? Okay. So the problem was that I was indexing not by the person, but by the event ID. I forgot to one extra level redirection. Okay. Well, how do I submit? Okay, that's 42 points. Okay, I'm going to pause my recording and go for a drink of water and a break. All right. Let me erase this code. Okay, let's make this problem. B bits of information in a single array. You query a bit position between 1 and B, and they receive that bit. After every first, 11th, 21st, 31st query is sent, but before the response is given, causes exactly one of the following things. The array is complemented. The array is reversed. Both complemented and reversed, or nothing happens. Figure out the entire array such that your answer is as accurate as of the time that you give it. Answering does not count as a query, so if you answer after your 30th query, For example, the array will be the same as it was after your 21st to 30th query. Interactive problem. Okay. You are encouraged to add more test case bits. Be advised that what is this? Local testing tool, Python code. I really want to know usage. Python local testing test number 0, 1, or 2. So how do I use this? Add your own case here. The one included here is just an example. It's not necessarily part of any real data set. How do I actually run this? Let me save this. So I run it as a pipe or something. Oh, I see. This is an interactive runner. Run this as Python interactive runner, Python testing tool. Okay. Okay, so I need a program that. Okay, what is the problem? I need to ask for a bit, get the bit back every 10th, first 11, whatever, every 10th one, I guess. Something random happens and you have to figure out what it is. B is equals to 10, B is equals to 20, B is equals to 100. Well, I guess B equals to 10 is simple. You just ask one bit at a time. No, it won't let you change before you finish. How many points are you at? Oh, 1 point. Yeah. Okay. Okay, so sample interaction. Okay, then let's see here. Initially, your program will read 2 integers T and B. T and T's number of cases. B is the same every case. Then process T cases. In each case, the judge begins with predetermined B-bit array. Up to 150 queries of the form. I'll put a signal number between 1 and B, indicating which position of in the array you wish to look at. If the number of queries you have made so far ends with a 1, chooses one of the 4 and ran uniformly, independently, and alters it. Judge responds with one line containing a single character 0 or 1. Or and if you prefer, okay, fine. Then after you've made as many of the 150 queries above as you want, you must make one more exchange of the following form. Your program outputs one line containing a string of B characters, each of which is a 0 or 1 representing bits currently stored in this array. The judge responds with one line, yes or no. If you receive yes, you should begin the next test case or stop sending input. Okay, so you only get one chance. If you say no, that's it. All right. What's this thing called? Oh, database written backwards. So I don't need any of these case things. Okay, I'm just going to do the B equals 10 case, just not because I don't want to solve the other ones. I want to make sure that I can run the interactive Python test locally. Otherwise, I might be a bit lost. Okay, so okay, with 100, but for now I'll just pretend that there are only 10. Then I'm just going to say for int I equals to I, 1, I less than B, I plus plus. Then I'm going to do what? See out I think that will flush it. C in AI, and then of course you need to remember that this is 1 based, 0 based. Okay, so this is just so that I can make sure I know how to run this thing. Okay, so I run Python interactive, and then Python testing 2, a local testing tool, py 0 minus minus dot slash database. Okay. Input is neither a number nor okay, let me run this program. One case, 10. Why was there a new line? Oh, I'm an idiot. Judge returns code 0. That means success. Does that mean success? I assume it means success. Okay. Okay. Okay, so now that we know how to get this to work, let's actually solve the problem. All right. So this solved the easy case, but I'm only using 10 queries. Okay, so let's start the whiteboard. So what can I do in 10 queries? I can get the first 10. But maybe I can get 5 and 5 like this. Why do I care about 5 and 5 like this? Because I might need to worry about reversing and checking. So I'll be able to get something like this, I guess. Whatever it might be, it doesn't have to be this way. Some strings, I can get 10 bits. Now, I have 4 things. I have complements. I have reverse. I have complements plus reverse. And I have nothing. So how do I quickly know which one is which? If I read one bit and it's changed, then I can rule out nothing. If it's not changed, I can rule out complement. So by looking at one bit, I can rule out one of those, either complements or nothing. What else can I rule out? Like looking at this first bit, I can also compare it with the last bit, and I can also rule out one of these two. Right? So if I see a 0, I know that it cannot be complement. I know that it cannot complement in reverse. If I see a 1, I know that it cannot be reversed, it cannot be nothing. So what if you have something? What if this last digit is 1? Okay, so if you see a 0, then you can rule out. Okay, so let's just think about it. If I see a 0, I can rule out complement. I can rule out reverse, but it could be complement and reverse. So then I can kind of look at if there's any position, if there's anything else along here that can allow me to rule anything out. Rule out one of the two. So in this case, let's say I see a 0, so I can rule out complement, I can rule out reverse, but I don't know if it's complement, reverse, or nothing. So then I look at the next character, and if I were to complement and reverse, I would get a 0. If I do nothing, so this, I will know that in one bit, if I look at this second bit, I would be able to tell which one it is, right? So in this case, what's the worst possibility? The worst case scenario is if you have this. Because if you complement and reverse or nothing, you can't tell the difference. But if you can't tell the difference, I guess you don't care. So I think in 2 bits, in at most 2 bits, you can figure out which one it is, which one of the 4 it is, or at least get it to which one of the 2 it is that is basically indistinguishable. And then it gives you 8 more tries to get the next 4. So the first one gives you 10, then you spend up to 2 bits to figure out which one it is. That allows you to get 8. The next one allows you to get 8, and so on. So 100 minus 10 divided by 8, that's 90 divided by 8 is about 11. That's got 12, rounding up. So you need 12 rounds, so that's 120 curries. That should be enough. Okay, so this is a little bit tricky to implement. So we have to be a little bit careful here. Okay, so at the beginning, the number of things that are known is 0. And we'll work towards beginning and end, so from both ends. You have to make sure that whatever I do, it's not going to break. No, it's okay. All right, so first round for I equal to 0, I less than 5, I plus plus. I'm going to say C out A bracket C out I plus 1. C in A I. You know something, I'm going to make it one base just so that I'm not constantly converting between 0 base and 1 base. Am I going to regret this later? I don't know. And then I'm going to ask for B plus 1 minus I Yeah, maybe I'm going to regret this. Using one base. Because okay, well, we'll just stick with it. Okay, so this is first while known is less than B, do something. Okay. And then for int I equals to 1, I less than equals to B, I plus plus, C out A bracket I. Okay, so I'm gonna just quickly check that this still works for size. Okay, and of course, if I were to do a bigger one, this will be infinite loop. That's expected because I haven't done anything. Okay. Now, what am I going to do? So I'm going to ask for, okay, so what are 4 possible cases? And how am I going to encode this? So it means nothing has been done. 1 means complement, 2 means reverse, 3 means complement and reverse. I'm kind of setting this up so that complement and reverse is kind of like the bitwise OR of complement and reverse, but I don't know if that actually matters. Okay, so I'm going to have some function that will apply the op. So if op, then for, okay, so my A needs to be passed in. I less than, wait, yeah, okay. AI is equals to 1 minus AI. Okay, so this is where I guess I use the bit mask. So I can apply both. It doesn't really matter which way you do it first. So what am I going to do? Okay, so I asked for the first one. What can happen if A0, right, A1 is equals to tab? Okay, so I need a mask, and I don't know which one. So I'm going to pretend that all of them are possible. So if they're the same, okay, maybe mask is not the best idea. Nothing is ruled out yet. Four possibilities. Okay. So if I look at it and haven't changed, then complement is not possible. but possibly minus minus. Anything that's otherwise, if they're not the same, then doing nothing is not possible. Okay. Now look at backwards. Look at it the other way. If the other one is the same as that, then I can get rid of reverse and complement. If it's different, then I can rule out reverse. Okay. Actually, maybe this is not the best way to do this. Okay, I'm gonna code a reverse. So I don't have to constantly checking backwards. So it'll be like this. Okay. Now what? Okay, actually I don't want to do that. Okay. So now I want a so now I have basically two things that are not ruled out. So that just copies, and I'm going to apply Okay, so I'm just gonna, now that I only have two possibilities, I'm just gonna transform them both. And then I'm gonna say for integers 0, I less than num over 2, I plus plus, if a temp 0, I so if the two are the same, then there's no point in asking more because there's no way I can distinguish them. Otherwise, cout, I know that I'm going to regret using one based. This cout I, I can actually start at I equals 2, but that's okay. I equals 2 because I already used I equals to 1 to rule things out. Why am I doing this? Okay, let me rewrite this. This is much. I can write this in a much better way. I'm just going to do this right at the beginning. I'm just going to apply all of them. And then position digit 1, moves none over 2, I plus position plus plus. Okay, I'm going to ask this is really overkill, but whatever. A temp I position s dot insert if s dot size is equal to 1 continue. Okay, so we only do it, we only make a query if okay, so if I haven't booted it out, I'd look at what's in there, and if they are the same, then there's nothing I can rule out. Otherwise, if it's not the same, then I can ask for that. And then I actually don't care about this anymore. No. It'll just work itself out if there's only one thing that's left. If a temp bracket I cost is not equals to temp, then rule out I don't think this actually matters. Okay, so what am I doing? I look at all the positions that I already know about. Look at what this is about, what each of the 4 that has not been ruled out yet, what is the value at that position. If there's more than one possible value in that position, then I ask. That will allow me to rule out some things. So at the end, I should have, oh, that's not true. It could be that I don't rule anything out, and I can't rule anything out. It's a palindrome, for example. But anyway, it doesn't really matter, because by the end, whichever one is not ruled out, even if there are more than one, they're all the same. So then I copy A temp I back to A, because that's the operation that I need. And now I can go on. So I have to remember how many I've done. So here, Q++, it should be an even number. Or maybe an odd number. If it's odd, I'm going to just actually waste one, because it's too tricky for me to figure out. I don't think that matters. I'm just wasting one. And then, so I'm going to ask, what am I going to ask? See out, so I know known plus 1 then I'm going to ask the other one, B plus 1 is B minus known. Minus equals 2. Known plus equals 2. Okay. Let's read this. Of course, my known is 2 times too big. Tries curry too many times. Okay, let's see. Okay, let me try a string. Like 20, so 1 0 1 1 0 1 0 1 1 1 0 0 20. That's 20. Just gonna put this into here so it's easier to see. Okay, so you asked me what is bit 1. So I'll tell you it's 1. Bit 20 is 0. 0. Bit 19 is 0. Bit 3 is 1. Bit 18 is 1. Plus 1. 17 is 1. 0. 0. Okay, now you ask me, so okay, before I do anything, I need to do a random thing. So I'm gonna just reverse the string. I'll just reverse. Okay, you ask me what is 1, and I tell you it's 0. What is 2? 0. Okay, so that means you know by now that I have reversed, and it's not complement. Good. So ask me 6, 0. 15 is 1. Why is it asking me 1? Because yeah, what the hell am I doing? Counting down and counting up at the same time. Well, that's good. Like in the largest case, it works. Well, maybe I submit it. Should I show test code? What's that actually do? Probably doesn't do anything. Submit attempt. Let's see what happens. Good, so why did I have to burn this one here? Because if it's odd, then I'm gonna get at 2 and I'm gonna get 9, and then when I try to ask for 2 things again, I'm gonna be out of sync. One of them will be before the flip, before the random thing, and the second hand would be after, and then I'd be completely screwed. That's why I decided to waste one here, because I have queries to burn, and that should be good enough. Okay, let's take a look at the last one. Another trace, another Latin square. It's a constructive problem. These are the kind of problems that I'm not very good with, but let's take a look. So N and K, the first line of the input gives the number of test cases, T test cases follow, N and K, okay, and K is the desired trace. Possible, impossible. It's possible, give a natural Latin square. Size up to 50 or size up to 5. Well, for the small case, there are really not that many Latin square. So you can probably just generate them all and see which one works. But definitely no way to do that for n equals to 50, so there must be something mathematical that we have to know about Latin square. Okay, I'm gonna stop this recording because I don't think that I can do this right now. I'm going to go away and think about it, and if I ever come back to it, I'll make another video.